When a light bulb explodes, it releases an energy equivalent to 1 billion nuclear bombs in a fraction of a second. Light bulbs are an integral part of our daily lives, illuminating homes, offices, and public spaces worldwide. However, have you ever stopped to think about what happens when a light bulb explodes? The explosion is a result of the light bulb's internal chemistry, specifically the reaction between the filament and the air inside the bulb. Imagine a grain of sand containing an entire library of chemical reactions, all waiting to be triggered. In the case of a light bulb, the filament is made of a thin wire of tungsten, which is heated to incredibly high temperatures until it vaporizes. The vaporized tungsten then reacts with the air inside the bulb, creating a chain reaction that eventually leads to the explosion. But that's not the strangest part. The explosion is actually a rapid release of heat and light energy, not a traditional explosion like you'd see in a firework. The rapid release of energy is what gives the light bulb its explosive properties, and it's a phenomenon that scientists have been studying for centuries. For centuries, scientists have been fascinated by the chemistry of light bulbs and the reactions that occur within them. One of the most interesting aspects of light bulb chemistry is the concept of the filament reaction, where the tungsten filament reacts with the air to create a chain reaction.
Imagine a series of dominoes falling in rapid succession, each one triggering the next, until the final domino falls and the light bulb explodes.
But what triggers the filament reaction in the first place? The answer lies in the heat generated by the filament, which causes the air molecules inside the bulb to vibrate and collide with each other. As the air molecules collide, they transfer their energy to the tungsten filament, causing it to heat up even further and eventually vaporize. It's like a game of cosmic billiards, where the energy transferred between molecules creates a chain reaction that eventually leads to the explosion. The speed of the reaction is breathtaking. In a fraction of a second, the light bulb can release an energy equivalent to 1 billion nuclear bombs. This is why light bulb explosions are so unpredictable and often result in catastrophic damage to the surrounding area. And then something unexpected happened. Scientists discovered that the explosion is not just a result of the filament reaction, but also of the bulb's internal chemistry. It turns out that the bulb's internal chemistry is a complex interplay of chemical reactions, including oxidation, reduction, and thermal decomposition. These reactions occur at incredibly high temperatures and pressures, making them difficult to study and predict. But researchers have made significant progress in understanding the chemistry of light bulb explosions, and their findings have far-reaching implications for various fields. From materials science to nuclear engineering, the study of light bulb explosions has led to breakthroughs in our understanding of energy transfer and chemical reactions. The impact of light bulb explosions is not limited to the scientific community. It also has practical applications in industries such as energy production and storage. For example, researchers have developed new materials and technologies that can harness the energy released by light bulb explosions. These materials and technologies have the potential to revolutionize the way we produce and store energy, and could even help us create more efficient and sustainable power sources. The study of light bulb explosions is a fascinating example of how science can lead to breakthroughs in unexpected areas. By studying the chemistry of light bulb explosions, scientists have gained a deeper understanding of the complex interactions between energy, matter, and chemical reactions. This knowledge has far-reaching implications for various fields, from materials science to energy production and storage. In conclusion, the explosion of a light bulb is a complex phenomenon that involves an intricate interplay of chemical reactions and energy transfer. From the filament reaction to the bulb's internal chemistry, the study of light bulb explosions has led to significant breakthroughs in our understanding of energy transfer and chemical reactions. The impact of light bulb explosions extends beyond the scientific community, with practical applications in industries such as energy production and storage. So the next time you turn on a light bulb, remember the incredible chemistry and energy transfer that occurs within it. And who knows, maybe one day, we'll be able to harness the energy released by light bulb explosions to create more sustainable and efficient power sources. If you found this fascinating, subscribe for more incredible stories like this. Want to learn more about the chemistry of light bulb explosions? Check out the links in the description below for more resources and information. And don't forget to like and comment below to let us know what you thought of this video. Thanks for watching, and we'll see you in the next video.